All right, started recording. I will scan, so at the end of each module, I will scan all the answers that we wrote. So even if I forget to record, they do get scanned. Because obviously, normally in person, we're not recording, and I got in the habit of scanning my notes for people. All right. Oh, that's weird. I should have put this slide before that. Remember, helpful geometry, right? The interior angles of a triangle all sum to 180 degrees. We used that rule earlier when we did that problem number 7 and 8. Sometimes, well, many times you'll encounter oblique triangles, particularly in when we're doing these force balances. And an oblique triangle is just any triangle that is not a right angle. So we can't use the SOHCAHTOA functions because those are only good for right angle triangles. And we can't use the Pythagorean theorem because, again, that is only good for a right angle triangle. But we do have other relationships we can use to figure out information that we need. Let's see. And there's just 2 examples of oblique triangles. And this is, you'd probably call this, a legitimate mathematician would tell you this is, I think there's a term obtuse triangle because the angle's obtuse, greater than 90. The first rule, or the first law we have, is the law of sines. And basically it tells you that you can set the ratios of the angle and the side opposite to it equal to the ratio of any other angle and its opposite side. So for example, the ratio of A, this length A, divided by the sine of its angle is the same as this length B divided by the sine of this angle, of its angle B, or also the same as the length C divided by the sine of its angle over here, right? So these ratios are equal to each other for a triangle, for any triangle. And this even works for right triangles because a right triangle is just a special case of a triangle. So we're going to use the law of sines for these 2 examples. Number 9, we're going to solve the triangle, and we're going to round the lengths to the nearest 10th. Same thing with number 10. So let's look at the information we're given. I'm going to pull up the picture again, or the document. All right. Find number 10 here too. Oh, there it is. Okay, so let's first look at number 9. The first thing we notice is we're given 2 angles and we're given one of the sides. I'm going to write out the law of sines here because that's what we're going to be using. So the first thing to recognize is I have an angle and I have the length of its opposite side. I also have another angle over here. I don't know its opposite side and I don't know this side. Also, because it's a triangle, I know what this angle should be, right? Because it's basically 180 degrees minus these 2. So we're going to get to that. Let's first figure out, let me write down the law of sines here first. A over sine A equals B over sine B equals C over sine C. So we're going to start off with, well, given the information we know, we're going to start off with these 2, right? The A and the C. So I'm going to set A over sine, well, let's rearrange this. I know what C is, and I know what the angle of A is, so I can find A as a function of all these other things. This is just simple algebra now, right? Ignore this one for a minute. A over sine A equals C over sine C. So that means A is just C times sine A over sine C. This is what I don't like using C. I should change this lettering. It's hard to tell the little c from the big C. Little c, big C. So now I have an equation for A in terms of things we know. What do we have? We have sine of 64. Oh, forgot to put the C in. I'll do that in a minute. Over sine of 82. And then we have the length C, right? 14 centimeters. So now you've got units to worry about. And what do we have here? We've got 12 point. Let's see, do I want to round this yet? I'll round it. 12.7. So A is 12.7. In fact, it's like 12.7068. And this is in centimeters, right? Don't forget your units. All right, now we know, well, we want to find B using the law of sines. We don't know this angle. So let's first figure out, find angle B. Find angle B first. So we're going to have obviously A plus B plus C equals 180, right? So B is just going to be 180 minus, what do we got? A plus C, which is 180 minus 64 plus 82. And this gives you an angle of 34 degrees. So we can write that in there if we want. It's always a gamble if I'm going to be able to fit my numbers in there. All right, so now we have a value for B. Now we can go ahead and use the same relationship. And we can use either one. We can use A, we can use C. I'm going to stick with C. C is a nice round 14 centimeters. So I'm going to look at this relationship now, right? B over sine B equals C over sine C. Again, get my pointer out here. I know what this is. I know what these two are. So I can solve for B. I'm going to have B equals C sine capital B, the angle, over sine of the angle of C, right? So that's just going to be, this time I'll remember my 14 centimeters in front. And then I've got sine 34 over sine 82. And this gives me, what does it give me? 7.9. So that's what B is, 7.9 centimeters. So we basically solved the triangle. And we use the law of sines. So this is using the law of sines. Are there any questions about this particular problem? All right. It sounds like you guys are algebra whizzes, I think, or trigonometry and whizzes. All right, let's do number 10. This is also law of sines. This should be pretty straightforward. The only thing here is that we got to label everything, right? Solve the triangle ABC. Oh, I didn't put any other letters. Well, I'll put letters here now. A equals C equals. All right. A is 40 degrees. B is 22.5 degrees. I'll write this backwards here. So I don't get squished into the crack there. What else? Oh, B is 12. What do I else do I need? 40. Yeah, that's it. So again, law of sines, right? Oh, we need to find the angle C. So C is just going to be 180 minus 40 plus 22.5 degrees, right? This is the internal angle. So C is going to be 117.5 degrees. Maybe I'll use blue for the answers that we know. 117.5 degrees. Law of sines, right? A over sine A equals B over sine B equals C over sine C. Now, if you forget this and as long as you remember the ratios, right? You could write them the opposite way too. You could write sine A over A equals sine B over B equals sine C over C. Just remember to write either all the sides on top or all the sine of the angles on top. It doesn't matter as long as you keep your state consistent with the ratio. What do I have? Oh, for the first one, I'm going to get A equals. All right, so I'm going to look at these two. So it's going to be B sine A over sine B. B sine A over sine B. And that's just going to be 12 over, what do I have? Sine 40 over sine of 22.5. So we see that A equals 20.2. I'll write this in. No units are given, so we're just writing these in as whatever they are, unitless numbers. And then finally we can do C. C is going to be, I'll use B again, B sine B over sine C. Or sorry, sine C over sine B. B sine C over sine B, right? So yeah, you can see very easy to mess it up if you're not paying attention. So what do we got? We got 12 times the quantity sine 117.5 over sine B is 22.5. I don't know why I did that. It is probably good to put parentheses so you can tell when you get sloppy writing like my own. 27.8. That's what it comes out to be. So we'll label this 27.8. So that's what C is. So yeah, that's solving the triangle using the sine rule. What do we have? One more rule, two more problems. Oh, yeah, that one uses. All right. Any questions about this one? All right, let's go back to the slides here. Law of cosines. You guys remember this one? Some of you? All right. What's interesting about this is you can actually see the Pythagorean theorem in it. Let's just go over this. So this is saying that we're referencing this triangle below, right? And the square of a side of the triangle is the sum of the squares of the other two sides minus twice their product times the cosine of their included angle. What the heck does that mean, right? The included angle. Let's look at the first equation. A squared equals b squared plus c squared minus 2bc cosine A. So where are B and C? B and C are over here, B and C. Their included angle is angle A, right? So A squared equals B squared plus C squared minus 2 times the product, right? Twice their product times the cosine of their included angle. And you can write this for any orientation of this triangle, right? You just have to know that, so if you, the point is, if you know two sides and their angle between them, you can figure out the rest of the, the other side of the triangle. So that's law of cosines. And you can see it being applied here, right? B squared equals A squared plus C squared minus 2AC cosine B. I'm not going to give you 3 equations. You can just basically know one equation and know that it's analogous, right? If you rotate it around, A is here, now it's B here, it's the other two with the angle B. C, you're looking at angle C and the other two sides. So, once you know one of them, you know how to use the other one. So we can use that to solve triangles. And again, we're going to apply this when we start having forces to figure out, okay, forces are acting, if you have a force acting along 2 points or acting along these lines at a point, right? Figuring out resultant forces based on that. That's what we're going to be using this stuff for. So let's go ahead and do this example. What is this, number 11? Where did I put number 11? Here it is. We're going to round to the nearest tenth and angle measurements to the nearest degree. So we can solve all the sides. I gotta do something about these figures. They're really blurry. We can figure out all the sides and then we can figure out the angles. And the first thing you notice here is, well, you're given an angle between two known sides, right? So right away we can think, oh, you know what? We can use the law of cosine. And once we find this, we can go ahead and figure out the angles using the law of sines. So we're going to use both techniques here. And let's just write this out. So I'm going to write out the general equation. A squared equals B squared plus C squared minus 2BC cosine A. Now, I want to point out here, you guys remember the sine and cosine of 90, right? If this angle was 90 degrees, the cosine of 90 is 0, right? So this term basically would disappear for a right triangle. And you wind up with the Pythagorean theorem, a squared equals b squared plus c squared, where a would be the hypotenuse, right? And b and c would be the, the sides that are at 90 degrees to each other. So this is accurate for every triangle. It just so happens that for a 90-degree triangle, right, if this angle were 90, this whole term becomes 0, goes away, and you're just left with the Pythagorean theorem. So if you know law of cosines, you know the Pythagorean theorem as well. This is all set up for me. So I'm going to take and write this under the square root. A equals the square root of all this stuff, right? B squared plus C squared minus 2B BC cosine A. I'm going to put in some numbers now. So I've got A equals the square root of, we've got B is 7, C is 8. So I'm going to have 7 squared plus 8 squared minus 2 times 7 times 8 cosine of 120. All right, so that's using the law of cosines. Let's evaluate these things. I'm going to have 49 plus 64 minus, if I put the numbers in, I wind up with, let me just check that because cosine, yeah, this should be negative. Yep. Times 8 times that, yes. So watch your math. This is a minus sign. Cosine 120 gives me a negative. So this whole thing is a negative 56. So we have 49 plus 64 minus a minus, which is a plus, right? So this is just 169, which equals 13. Oh, isn't that convenient? So A is 13. Now, if we want to find the angles in here, let me just, you know what I'm going to do? I'm just going to make the angle. I'm going to label them. I mean, they're already labeled by virtue of the corner. Now it's much simpler for us to, I mean, we could use this equation and back out the angle this way, but there's a lot of math going on here. So we just use the law of sines again. And let's see, the first thing I can do is I can figure out, let me write out the law of sines. We know A, little a and big A. We know all the sides, so we can just work out their angles, right? So we can figure out the sine of the angle and just take the inverse sine, right? So sine of B is just B over A or times sine A, right? So see it algebraically. We're going to bring this over sine B. We're going to bring the A under, and we're going to bring the sine A. So we're going to have an equation like this. Sine of B equals B over A sine A. So to actually get B, B is just the inverse sine of B over A sine A. And that's going to be inverse sine. What do we got? 7 over 13 sine of 120. Let's do this to make it look normal. So B is just, what do I get? I get like 27.796. 27.796. B equals 27.8 degrees. Oops, gotta move that up. Yeah, I'm running out of space. Oh, the last one is C. We're gonna do the same thing up here with the, we can use C and A. A is a nice round number here. So I'm just gonna rewrite this. You basically write the same relationship. Sine of C equals C over A. C over A sine A. And then we've got C is just the inverse sine of C over A, sine, big A. All right, if we plug those numbers in, we have C is the inverse sine of, what do we got? C is 8, A is 13, then we have sine of 120 again. And this gives you C equal to 32.204, which is also equal to 32.2 degrees. So we've got A equals 13, B is 27.8 degrees, C is 32.2 degrees. And I could write those on the triangle as well. What do I have? B 27.8. 32.2. Oh, it's almost 12:50. I thought I'd get to the last one, but yeah, you know what? Why don't you do number 12 on your own? And next class, I'll just go through it really quick. So, are there any questions about number 11? So notice we had to use the law of cosine and law of sine. Number 12 is similar. So why don't you go ahead and do number 12 on your own, and I will go over it next class, but there's just not enough time to go through it. So it's probably best just for you to try it. You can even try it on a scrap paper, and then first thing on Wednesday, I'll go through it, see if there's any questions, and then we can start the next module. All right. So if there's no questions, let me stop recording.